RC Group has for decades played a leading role in the design development of the precision cooling equipment market, presenting engineering solutions for the various types of green data center with innovative and high-tech products. Green data center solutions. 3 types can be identified. Data centers of large capacity and high heat loads, used today by international banks, telecom operators and cloud computing service providers. Data centers of small-medium size, but with features and requirements similar to those of large capacity. Data centers or parts of them with hotspots or very highly concentrated thermal load, located in specific areas. Let's now analyze the green solutions developed by RC Group for each of the 3 types of data centers. Large data center. The best solution from energy point of view is the use of a chilled water system, mainly consisting of the air-cooled chiller, glider-free, with free cooling sections, coupled with high-capacity chilled water precision air conditioners, next CWKL. The free cooling section allows the glider-free to start producing chilled water, utilizing only the energy required by the fans, when the outside air temperature is only 2 degrees lower than the chilled water system return temperature. When the external air temperature no longer permits full capacity free cooling, the glider-free works in a combined mode, maximizing the thermal exchange of the free cooling coil and compressors, having modulating capacity control. Main components are electronically commutated EC axial fans and screw compressors with stepless capacity control. The chilled water produced by glider-free chillers feed the large capacity precision air conditioners next CWKL, utilizing EC electronically commutated plug fans in a separate plenum installed under the raised floor. This technical solution allows the use of large surface heat exchangers with a consequential increase in cooling performance within a small footprint. Standard equipment includes 2-way modulating chilled water control valves, allowing the use of variable speed inverter-driven pumps. Medium data center. For the medium size of data center, the use of chilled water systems will be too costly, and therefore the best solution is most often represented by a direct expansion air-cooled, water-cooled system, consisting of room units installed directly within the data hall and matched to remote dry coolers installed on the roof. Main components for each air conditioner are EC electronically commutated plug fans and inverter-driven scroll compressors with stepless capacity control. The combined operation of the inverter-driven compressor and EC fans respond in real time to thermal load changes within the data center and realize substantial energy savings. Data center with hotspot. For data center hotspots with areas of high concentrated thermal loads, the best solution is represented by the direct expansion cool site system, consisting of indoor DX evaporator units and outdoor air-cooled motocondensing units. The indoor units are equipped with EC plug fans and are available with 2 airflow options: in row for installations with hot aisles and cold aisles, in rack with air supply and return inside the rack. Up to 3 indoor evaporator units can be matched to each single outdoor motocondensing unit, being complete with EC motor-type axial fans, inverter-driven scroll compressor, and aluminium-aluminium microchannel type condensing coils. The cool side indoor units are also available in a chilled water version for combining with one of the many types of RC Group liquid chiller options, a new concept of standby. RC Group's extensive use of highly energy-efficient components such as electronically commutated EC fans, inverter-driven compressors, electronic expansion valves, and sophisticated microprocessor control systems has revolutionized equipment performance at part load operating conditions and changed the concept of the operation and management of standby equipment. The highest values of EER can be reached with all units operating at partial load. This is a contradiction of the old philosophy of operating some units at full load and retaining others on standby. Measurements performed recently on several installations have shown an important increase in EER and a consequential reduction of the PUE index.